relate the field classification, the field, the strength in terms of the shear strength value, okay, and the UCS value with the strength description. Okay, so the definition, so if the soil is very soft, easily penetrate centimeter by fist, then if soft, you can use your thumb, just penetrate with your thumb easily. And then if firm, you have to you can use your thumb but with a moderate effort to press the soil. Okay, then this on. Okay, alright, so far I think you can clearly understand. Okay, so now we go to the next major or the important lab test, which is shear strength, to get the shear strength properties. So normally we have for shear strength, we have direct shear test, then we have triaxial compression test. So this one we have a UU test, we have a CU test, and we have CD test, and then we have UCT test. Okay, so what are the difference? Okay, so this is the shear board test. So your sample would be here. Okay, so this the gauge and the load here. So you will get points for different stress, with different pressure load that you apply here. So you have 10, 20, this is 26, 25, and then 40. So you will get the straight baseline, best line, and then you will get the C value. This is the C value, cross your y-axis, and then you will get phi is angle of the slope. Okay, angle of the slope. Okay, angle of the slope, this is phi, and then yeah, that is it. Okay, this is C, cross this is C. Okay, okay, then triaxial compression test. So triaxial compression test, we have actually quick undrained QU, and then we have UU, unconsolidated undrained. We have CU, which is consolidated undrained test, and then we have CD, which is consolidated drained test. Okay, so this is the triaxial equipment. So this is the specimen or your soil. You put it here with the membrane, and then here full of water in this equipment. Yeah. Okay, so full of water here actually. It's full of water right here, full of water. Okay, so what's happening actually? So water inside here, water inside here that will fill up this equipment here. Okay, it's actually represent the confining pressure. So confining pressure is from top, sides, and bottom. So all around pressure, that is sigma 3 confining pressure, all around the specimen. Okay, that is sigma 3. Okay, then once you apply the load here, during the shearing stage, okay, remember triaxial, okay, actually it has three stages. Stage number 1 is saturation. Stage number 2 is consolidation. Stage number 3 is shearing. Okay, that is how you get this its name. CC, if you conduct consolidation. UD, if during shearing you close the valve. If you close the valve, so you there is no water coming out from the specimen, so undrained. Okay, no drainage during shearing, no drainage. You close the valve, so it's undrained. If during shearing, okay, shearing either drain or undrained. Okay, if you open the valve, yeah, if you open the valve and the water can come out from the specimen, okay, meaning that you allow the drainage, so it's considered as drained. So that's why the test is consolidated drain, because during the test, the triaxial test, okay, you do the saturation, you do the consolidation, and during shearing you drain out the water, so we call consolidated drain. Okay, if you do saturation, you do consolidation, but during shearing test you close the valve and no drainage, so no water out from the sample, so we call it consolidated undrained. Okay, so this unconsolidated undrained, okay, so unconsolidated undrained, you do the saturation stage, stage 1 saturation, but you did not do the consolidation, that's what unconsolidated. Okay, after the saturation stage, skip to shearing, so there's no consolidation stage, so you directly skip to the shearing, but during shearing you close the valve, so no water coming out from the sample, so it's considered as undrained. So that's why you test is called unconsolidated undrained. Unconsolidated because no consolidation stage, saturation stage, skip to shearing, but during shearing close the valve, so no drainage, so that's what undrained. So that is how we get this type of test. For quick undrained, okay, for quick undrained test, you skip saturation, you skip consolidation, you directly do shearing. So during shearing, close the valve, so no drainage, so that is why quick undrained. Okay, no saturation stage, no consolidation stage, immediately do the shearing stage, but during the shearing stage, what you do, you close the valve, okay, so no drainage, so means that no water coming out from the specimen. Okay, so it's considered as undrained. Okay, so now you know how the type of why the test is different, because based on what you conduct during this all these stages. So triaxial test has three stages, saturation, consolidation, shearing. Okay, so either you open the valve or you close the valve, either you do the consolidation stage or did not do. Okay, you skip the consolidation, so you will get QU, UU, CU or CD, depends on whatever steps that you do. Okay, so this one sigma 1. Okay, sigma 1, how you get that sigma 1? This sigma 1 is actually from the load. Okay, the load that you apply here. So when you apply the load, so means that you apply an additional load. So this is the additional load. Okay, you apply the load means that you increase the load, so that means that you there's an additional load. Okay, so that is additional stress. So that additional stress plus with that already all around stress, sigma 3, so that is your sigma 1. Okay, axial. Okay, axial. Okay, axially. So that is triaxial compression test. Okay, so you still remember more circle? Okay, so what is more circle actually? Okay? What is more circle actually? So when you do the first test, the first load, let's say 30 kPa, and then okay, let's say your sigma 3 is 30 kPa. Okay, 30 kPa, and then you add 60 kPa, so your sigma 1 would be 90 kPa. Okay, so this would be 90, so this is 30, and then you increase data sigma, you increase let's say you increase 80 or 100. Okay, so now sigma 3 is still 30, but your sigma 1 now is 130 kPa. So this is 130 kPa, but your saw is still not fail. Okay, why still not fail? Because still not touch this strength envelope, okay, strength envelope. So next you increase the stress. Okay, you increase to 200, let's say 200. So your sigma 3 is still 30 kPa, but you increase 200 kPa, so now your sigma 1 is 230 kPa. So now it's 230 kPa. Okay, and now this molecule touch this strength envelope. So once this touch the strength envelope, means that the salt is fail. Okay, fail. So this is fail. You can see that one, correct? The salt fail. So once it touch the strength envelope, so the salt is fail. But these two, this envelope and envelope 1, this envelope 2, still not touch this strength envelope, so means that this additional stress is still in safe condition. Okay, that is what is actually musical. Okay, what is the story behind the musical? Okay, so these are the data. Okay, the data. Okay, the strength envelope, I said just now, the strength envelope, this strength envelope is based on this one. It's actually C is this one, this is C. Okay, so phi is this one, angle friction, this angle slope of this slope, that's angle. So when you, this is this line. Okay, let's see. So this is C, this is in the different color. Okay, this is actually tangent, this is phi. Okay, so this, okay, S, shear strength, this is the shear strength. Okay, this is shear stress, this is shear stress, sorry, this is normal stress, this is normal stress. Okay, this is shear stress, shear stress. But once it touch, so this fail. So this is the shear strength for this particular stress. So this particular stress, when it's touched, so this is the shear strength of this particular stress. Okay, so for effective, because we have total stress and effective stress, so effective stress equal to total minus U. Okay, total minus U. So remember, do you still remember three-phase diagram? three-phase diagram. Solid. Okay, so this is solid, this is water. Okay, so total stress for all means that solid plus water. Okay, U is only for water. U is only for water. So this is only for water. Effective stress only for solid. Okay, so when we say effective stress of the source, means that the stress is ditanggung. I can't remember the English word. Okay, ditanggung sepenuhnya oleh solid. Okay, so means solid means that the soil fragments, okay, particles. Okay, so total stress, if total stress means combination of solid and water. Okay, total by water and solid. If for water pressure means that a pressure from water only. Effective stress means that stress from solid only. Okay, why we call for water we call pressure? Because water is a special, it's unique, so we never call it for water stress. No, never. So for water, special for water, we use pressure. Okay, for water pressure, water. Okay, so next, so this is for unconfined. Unconfined, why unconfined? If you can see here, the sample here, there is no water confining the sample, the specimen. Okay, not like Triaxial, we have water confining all around this specimen, but for unconfined compression test, so there is no water confining all around this sample. Okay, so when unconfined compression test, so the clue is, okay, the clue is sigma 3. So there's no confining pressure, right? Okay, no confining pressure, so sigma 3 is equal to 0. So only that we have sigma 1. So sigma 1, this is also means that equals to sigma 3 plus delta sigma. Okay, but sigma 3 is 0. So this sigma 1 is equal to delta sigma, which is deviator stress. This one, delta sigma, or sigma d, which is deviator stress. Okay, so because of phi u is equal to 0, so C is equals to C or SU, because certain books use C, certain books use S. Okay, so CU, this is CU is actually equals to SU. Okay, SU or CU is undrained shear strength. Okay, undrained shear strength. Okay, undrained shear strength means that this sigma d, deviator stress, divided by 2. Why divided by 2? Because this is the diameter, so this is the radius, this is the diameter. Okay, so the clue for unconfined compression test, first clue is that sigma 3 is equals to 0. Okay, sigma 3 equals to 0. CU is equals to sigma d divided by 2, or QU, unconfined compression strength. Unconfined compression strength divided by 2, so you will get CU. Okay, so in your question, so normally sometimes in the test or quiz or whatsoever, we give you information just stated that based on unconfined compression test, or we just give you unconfined compression strength of the cell is 200 kPa. So then you have to calculate so on. So from that, you directly or indirectly, you will get the CU value and phi u. Okay, unconfined compression strength, so means that undrained. So undrained, so phi u equal to 0. Immediately you know phi u equal to 0, and you know Cu is half of your unconfined compression strength. Okay. Okay, the next laboratory consolidation test is odometer test. This is what we usually do, odometer test. So this is your specimen. So porous stone, top and bottom, because you want it to be two-way drainage. Okay, two-way drainage. Okay, two-way drainage. So the water expel out to the top and also spill out to the bottom. So two-way drainage much more faster, right? Compared to if you only have porous stone on the top. This is not porous stone, so the length of the drainage would be longer compared to if porous stone, so halfway, right? So much more faster to complete the primary consolidation. So this is the graph that you have to plot based on the odometer test.